In May of 2022, a spacecraft 14 billion miles from Earth started telling its engineers something that, according to every readout on the ground, simply could not be true. Voyager 1 was still flying correctly. Its antenna was still pointed precisely at Earth, still successfully sending back real scientific data from interstellar space, still receiving and executing commands exactly as it should. And yet the specific system responsible for reporting on the spacecraft's own orientation and health had started transmitting information that didn't correspond to anything the spacecraft could actually be doing. Not garbled noise, not silence, structured, seemingly deliberate data describing a state the engineers knew with certainty was physically impossible. For months, nobody at NASA could explain it. And when they finally did figure out what was happening, the answer turned out to be stranger and, in its own way, more unsettling than almost anyone on the mission team expected. To understand why this particular glitch unsettled engineers who had spent decades working with this exact spacecraft, you need to understand what the affected system actually does. It's called the Attitude Articulation and Control System, AACS for short. And it's responsible for keeping Voyager 1 correctly oriented in space, most critically, keeping its high-gain antenna pointed with extreme precision directly at Earth. Get that pointing wrong, even slightly, at a distance of billions of miles, and the spacecraft loses its ability to communicate entirely. The AACS is, in a very real sense, the reason Voyager 1 has a voice at all, the system that makes it possible for every other instrument on board to actually report back what it's found. Starting in May of 2022, that system began sending back telemetry, the routine stream of health and status data engineers rely on to monitor exactly what the spacecraft is doing at any given moment. That simply didn't make sense. According to NASA's own public updates at the time, the data appeared, in some cases, almost randomly generated, and did not reflect any state the AACS could plausibly actually be in. This wasn't a case of missing data or corrupted, unreadable static. It was clean, structured information describing a spacecraft orientation and operational state that the engineering team knew, based on every other signal they were receiving, simply wasn't real. Here's what made the situation genuinely disorienting, rather than simply annoying. Every other sign coming from Voyager 1 suggested the spacecraft itself was completely fine. Its antenna remained correctly pointed at Earth. It continued gathering and transmitting real, usable scientific data from the interstellar environment surrounding it. None of the spacecraft's onboard fault protection systems, the automated safeguards specifically designed to detect serious problems and shift the spacecraft into a protective safe mode, had triggered at all. By every practical measure, Voyager 1 appeared to be operating exactly as expected. Only the specific telemetry reporting on its own internal status had become, for reasons nobody could initially identify, fundamentally unreliable. For a spacecraft sitting this far from Earth, that kind of uncertainty carries genuine weight. Every command sent to Voyager 1 already takes many hours to arrive, with any response taking equally long to make the return trip. Diagnosing a problem under those conditions isn't a matter of running a quick test and getting an immediate answer. It's a slow, methodical process of forming a hypothesis, sending a carefully chosen command built to test that specific idea, and then waiting the better part of a day, sometimes longer, just to find out whether the theory held up at all. Engineers spent months working through exactly that process, testing possibility after possibility, trying to understand why a system that appeared, by every other measure, to be working correctly, kept insisting on describing a version of the spacecraft that didn't actually exist. The eventual answer, when the team finally tracked it down in August of 2022, turned out to hinge on something almost nobody had initially considered. Voyager 1's attitude control system wasn't actually broken. It had simply started routing its telemetry data through the wrong place, specifically through an onboard computer that had stopped functioning years earlier. That dead computer, still physically connected to the rest of the spacecraft's systems, even though it hadn't been actively used in a very long time, was corrupting the information passing through it before that data ever made it back to Earth. The AACS itself was healthy the entire time. It was simply, for reasons still not fully explained, sending its perfectly good data through a piece of hardware that had no business handling it anymore. And once engineers suspected this was the actual cause, the fix itself turned out to be almost anticlimactic compared to the months of investigation that preceded it. The team simply sent Voyager 1 a command instructing the AACS to resume routing its telemetry through the correct functioning computer instead. It worked. Clean, accurate data started flowing again almost immediately. Suzanne Dodd, Voyager's project manager at NASA's Jet Propulsion Laboratory, described the team as happy to have reliable telemetry back, while being candid that the underlying question, exactly why the AACS had started using a dead computer in the first place, remained genuinely unresolved even after the practical problem had been fixed. Part of what made even diagnosing this issue so difficult was the sheer age of the spacecraft itself and the reality of trying to troubleshoot hardware and software designed and documented nearly half a century earlier. Voyager 1 launched in 1977, built using engineering practices, documentation standards, and computer systems that predate almost every convention modern spacecraft engineers now take for granted. According to members of the team working the problem, part of the eventual diagnostic process involved digging back through decades-old paper manuals and original mission documentation, material written and filed away long before most of the engineers currently working the case had even been born, simply to properly understand exactly how these specific, deeply outdated systems were originally designed to behave in the first place. Modern spacecraft missions maintain far more robust, centralized digital documentation, specifically because missions today are expected to run for many years. Voyager was never built with that same expectation in mind, and nearly 50 years later, that gap in institutional memory became a genuine, practical obstacle standing between the engineering team and a straightforward diagnosis. There's a broader pattern worth noticing here because this wasn't an isolated incident in Voyager 1's recent history. This 2022 AACS telemetry mystery was, in hindsight, an early instance of a specific kind of problem that would recur again in a different form the following year. When Voyager 1's flight data system began transmitting genuinely unreadable, corrupted signals for a 5-month stretch starting in late 2023, ultimately traced to a single failed memory chip that had quietly deteriorated after decades of continuous exposure to cosmic radiation. Different systems, different specific causes, but the same underlying story repeating itself. A spacecraft built in the 1970s, running continuously for far longer than any of its original engineers ever expected, gradually revealing small, cumulative failures in its oldest, least monitored components, each one requiring the current mission team to become, in effect, detectives working a decades cold case, armed with little more than old documentation, careful reasoning, and an enormous amount of patience. What makes the 2022 AACS mystery particularly worth understanding properly, rather than simply filing away as one more impossible headline, is what it actually reveals about a mission at this stage of its life. Voyager 1 wasn't lying to its engineers, and it wasn't malfunctioning in any dramatic, catastrophic sense. It was doing something subtler and, in its own way, more human, quietly misreporting its own condition, not because anything was fundamentally broken, but because a piece of its own aging internal infrastructure, a computer nobody was actively relying on anymore, had failed silently years earlier, and only became a problem once new data happened to get routed through it. It took a dedicated team of engineers, working patiently across a communication delay of many hours per exchange, digging through nearly 50-year-old documentation, to eventually understand exactly what their own spacecraft was, quietly, mistakenly telling them. That's the real story behind headlines calling this an impossible discovery. Not an alien signal, not a message from beyond, not evidence of anything the models couldn't account for out in interstellar space itself. Just an old, remarkable machine, still faithfully doing its job nearly 45 years after launch, momentarily unable to correctly describe its own internal state, and a team of engineers on Earth patient enough and thorough enough to actually go find out why. If stories like this, the ones where the real explanation turns out to be a careful piece of detective work rather than a mystery beyond understanding, are what you come here for, stay close, because there is more still waiting in the archives of a machine that has been quietly surprising its own engineers for nearly 50 years.